We can move on to the next speaker, which will be Yuji Higo. So from the Spring 8 synchrotron, and he will be telling us about current status and future plans for the BL04B1 beamline.
So my name is Yuji Higo, beamline scientist of BL04B1 at Spring 8. So this beamline is a large volume press beamline. So in this time, I will talk about this title. And also I talking from my beamline. Can you see? So if you have some question of this beamline, I can show you right now. So next. Oh, sorry. So I change the slide. Okay. I think most of you not knows much about this beamline. So I will briefly explain the overview of this beamline. So these two large, shows a laser point. So these two large volume press are installed in this beamline, and these are maximum load of 1,500 tons. So in this beamline, white X-ray from bending magnet and can be used and can be measured XRD measurement using energy dispersive method. In addition, the small double crystal molecular is installed, and also can doing angle dispersive XRD measurement using large area CC detector. And for cameras installed this beamlines. And the front first experiment hatch is used for the conventional energy dispersive XRD measurement and the X-ray image radiography experiment using white X-ray beam, white X-ray. The high pressure press and the X-ray optics are kept at the same setting, so experiment can be performed in a stable environment. So this press mainly used was a equilibrium experiment, falling sphere experiment, and also ultrasonic experiment, and so on. So this is an example for a falling sphere imaging experiment. It's same as the previous talk. So we show you the movie here. So which allow us measurements the viscosity of low viscosity melt by high speed time resolver imaging. So, and also this is an example of elastic wave velocity experiment. In this beamline, they're using a high resolution X-ray absorption image to measure the sample length, and the energy dispersed XRD data. It used was estimate of density, and very high resolution ultrasonic measurement system. It can know the travel time of the ultrasonic wave. It's these three data set can estimate the elastic velocity to the topmost of the lower mantle condition. And also next is the bottom stream side speed Mach 2. This experimental hatch allows us to conduct very high pressure experiment using sinter diamond anvil. It's about 100 GPa, and also deformation die apparatus can be used for the deformation experiment. In addition to the generation, and in addition, and the germanium detector and white X-ray, and also a large area CCD detector using for the monochromatic X-ray with energy 30 to 60 keV. So I will. This is an example of acoustic emission experiment using the deformation dial apparatus. In this experiment, the Vedic stress of the device, the night sample, is increasing by DRAM pressure, and microscopic sample strain was detected by radiography, the formation radiography, and also the formation of main fault was detected from acoustic emission measurement. The changing of the frequency of acoustic emission also measured by continuously using this system. And also in the ultra high pressure generation using a sinter diamond ambience, we have succeeded to generate pressure exceed 120 GPa using a commercially available sinter diamond ambience. We have also made a nano polycrystal diamond ambience by hand and trying to generate higher pressure using this sinter NPD diamond. Currently, the pressure generation is only about 100 GPa due to the lack of the strength of this second stage ambience, but now progressing, developing. So this is from this from here, the main talk will start. So here is the introduction of the current status of beamline. But next, our future plan is to develop the beamline to understand the dynamics of it involved in the mantle convection and plate tectonics. In addition, the existing D-dia press and also we need a very P-type press. It was a very wide opening, and also D111 type press was a deformation experiment at a higher pressure. So moreover, high energy and high flux X-ray source are required for first time resolve measurement of fast phenomena such as brittle fracture and large brittle fracture, and also for imaging a large area X-ray source also required. So we have already introduced the D111 type guide block in this year. So we have made mold the replaceable existing D-diodes and can be replaced in just 2 hours. We have already confirmed that it is possible to perform the deformation experiment at up to 30 GPa. So, and also I conducted test experiment of high energy and high flux X-ray for high-speed time resolve XRD measurement with large volume press. And this experiment did the BL0405XU. This is undulator beamline, so which is installed with a multi-layer mirror. It can generate very high energy pink beam. It is 100 kb, and band wide is about 1%. So I bought the P press to this beamline for testing experiment high speed time time division XRD experiment. So this P press was used was this you can see this P press was used was a high pressure press, and the detector was lambda 750K. This is a cadmium telluride pixel detector or first time resolve measurement. In addition to the imaging plate, you can see here, for the checking the entire debris link. So P press and lambda detector and the IP and the camera. This all the set installed to the BL05XU. The first I tested the time resolve measurement using cerium oxide standard sample and confirms the diffraction line could be observed even with exposure time of 1 millisecond, and that the signal noise ratio was enough analysis with exposure time about 100 milliseconds. This is lambda detect from lambda detector, and this is imaging plate entire debugging from using a pink beam. And next we conducted a high pressure experiment using polyagent press. The KCl, you can see KCl was used for the sample. And first we pressurize the sample to 3 GPa, and to make high pressure phase B2 phase appear, and then I release the oil pressure very quickly and try to observe the peak change during the decompression process. I want to see this cross section of this, but in this experiment under room temperature, so it not completely change to B2 phase, the mixing of B1 and the B2 phase. So so I changed the figure, so you can see movie. Okay, so this movie is the exposure time is 100 milliseconds, and this movie is 10 frames per second. So it is a real-time movie. Initially, we intended to see the change in the diffraction line of KCl, but as the high pressure cell moved down as the pressure was released, the diffraction line of the molybdenum, you can see here, molybdenum appear and you can see this dot is from alumina at the top of the sample appears. So first you can see this KCl, but when start to release the pressure, you can see this molybdenum foil and this alumina. So so you can see next, but looking at the peak in the more detail here, I found the transformation from B1 to B2 phase occurred in about 1 second. This single line, this between the lines about 1 100 milliseconds. So all this time is 1 second. You can see this is these two peaks before decompression, and you can see after decompression, the only after, not after the first stage of the decompression, this only B1 phase you can see here. And also the molybdenum foil growing here, and but no alumina phase not appear in this time. So
1 minute.
okay, so I will continue to use this beamline for high pressure experiment. We are currently making a new high pressure press for conducting the full scale high pressure experiment using this high energy, high flux, high flux beam. The concept of the new apparatus is to make it easily movable and to make the press body to right weight so that the stage can follow the high speed movement of the sample. So this is the drawing of this new press. The maximum load about 200, and it makes very lightweight. And this is a stage of this press. It can movable to install this very high flux beamline. So this is a summary of talk. So okay, thank you very much for attention.
Thank you very much for your nice talk. Do we have any questions from the audience? Yes, we have one question from Yan Bin. Please go ahead.
Thank you, Higo-san, for the nice talk.
Yes, thank you.
Can you describe a little bit about the plans for the Spring 8 upgrade?
Yeah.
For your beamlines, please.
Yeah, so it's a difficult situation of the Spring 8 2 plan. So now I think that the detail of plan now changing a lot. So I can say the situation of the next next generation. So, but in this plan, the bending magnet beamline is I think is not good, because the multi-bending automatic plan, the bending light source is the intensity is very, very low. So now I will move to the ID beamline. Yeah. So now, but now I using white beamline, white X-ray and monochromatic X-ray both in one beamline. But the next I will separate the white X-ray and only and monochromatic X-ray only. But not decide. So
okay, will you have a Wiggler beamline or a
not
beam?
Wiggler, not. I think it's in a plan, undulator and bending beamline, I think.
Okay, thank you.
Okay, thank you very much for your talk, Yuji.